Please turn to this page in your notes and follow along. The last few lessons we've been talking about data. The first one we looked at sampling techniques, and the next one we looked at collecting data. So once you have your data, what do you do with it? Well, you usually want to display it somehow. So that's what this lesson is going to be about. Looking at how to display data. And there's two types of data in general. Categorical and numerical. So categorical data is data that are categories or types. They're not numbers. Whereas numerical data is data that's expressed as numbers. Sometimes when you have a survey question, you're asked, what's your favorite color? What's your favorite sports team? Or what country do you live in? These are all examples of categorical information or data. Numerical data is something else. So you can have different types of numerical data. You can have continuous numerical data or discrete numerical data. So continuous data is numbers that can have any value within an interval. Whereas discrete, you can only have certain numbers. They can only be counted, like 1, 2, 3, 4, 5. Whereas continuous, you can have values in between 1 and 2, like 1.5 or 1.78 or 3.14159, whatever. So, for example, time is continuous because if I start my stopwatch right now, I can have 1 second, 2 seconds, 3 seconds, but I can also have the entire infinite span of time between 2 and 3 seconds. Discrete, on the other hand, an example of that would be number of people. I can have 1 person, or 2 people, or 3 people, or 4 people. I can't have 3.5 people. That just doesn't make any sense. This is numbers that I'm simply just counting. 1, 2, 3, 4, 5. The reason I'm talking about all this is because depending on what type of data you have, that tells you how you can best display that data. So that's what I want to look at next. Different ways of displaying data. We'll start with bar graphs and circle graphs. So when do we use bar graphs and circle graphs? Well, if your data is categorical data, of course you're going to use a bar graph or a circle graph. Now we sometimes call them pie charts too. So for example, here I have freshmen, juniors, sophomores, seniors. These are different categories. So I'm going to use a circle graph. Here I have camping equipment, golf equipment, mountaineering equipment. These are different categories. So I'm going to use a bar graph to represent them. These look like bar graphs, but they're not. These are called histograms, and they're used for displaying continuous data. So this is numerical data that is continuous. So for example, you can get results of a math test. So you can have any value between 0 and 50 on this math test. You're not limited to whole numbers. So you could get a half mark on a test or something like that. So when you have continuous data, you have a continuous scale along the bottom. The bars show you how many times, so that's the frequency, is how many times you get a value in this interval. So the way I would read this graph is there was 1 test with a mark between 0 and 10. There were 2 tests with a mark between 10 and 20. There were 3 tests with a mark between 20 and 30, and there were, 5 tests with a mark between 30 and 40, etc. Okay, so it looks like a bar graph, but it's not a bar graph. So here I show you the difference. Basically, it comes down to gaps. Bar graphs, you put a gap between the bars. They're separate categories. They are not connected, so the bars are not connected. In a histogram, you have continuous data. The bars are connected because you can have all the values within this entire range. There's no separation of the data, so there's no separation of the bars. You're going to see histograms a lot in this course. This is the one we're going to focus on the most. But we also have line graphs. Here's an example of a line graph. You can see you've got the years along the bottom. Years, well, that's time. This is continuous data. So it would not make sense to use a line graph for categorical data. Let's say you were graphing favorite colors. It doesn't make any sense to have a line graph. Whereas here I have how the number of horses and the number of tractors changes over time. It would make no sense for me to use a bar graph here because that doesn't support the type of data that we have. Let's work through some examples. So here I have some data. I have expenses and the amount spent in each of those different areas. So I have entertainment, clothing, cell phone, and lunch. Spent $100 here, $225 here, $50 and $75. So let's classify the data as either categorical or numerical. Well, let's just take a look. We've got different categories right here. Entertainment, clothing, cell phone, lunch. Those are different categories. They are not connected. They are not numerical. So we have categorical data here. So because of that, which type of graph would best suit the data? Well, if it's categorical data, we are looking at using either a bar graph or a circle graph. Okay, so now we're going to sketch out how we would make a bar graph and how we would make a circle graph for this information. Well, we set up our X and our Y axes. We put our categories along the bottom and our amounts along the side. Set up your scale for your numbers. Try to be consistent with the amount of space between each. Since I'm just doing a sketch, I wasn't being incredibly accurate. And your different categories along the bottom, you just want to make sure they're evenly spaced. And when you put your bars on, just make sure they're the same width. And you have about the same amount of space between each, just so it's evenly spaced out. Well, now we're going to use the same data, so I have it listed just in a different table here. We have our expenses and our amounts for each expense. But this time we're going to make a circle graph or a pie chart. This is a little more difficult to figure out how to do it because you need to figure out how big to make each wedge of the pie. So we're going to work through this table that I've set up here, and I'm going to show you how to figure out how to calculate the angle that you'll use in your circle to find the size of the pieces of the pie. First off, you want to get the total for all of your amounts. So we're just going to add these up. 100 plus 225 plus 50 plus 75. We end up with a total of $450. Okay, so now we're going to figure out what percent of the total is each expense. So for entertainment, we're spending $100 out of the total $450. So I can set that up as a fraction. I can do 100 divided by 450 to get this as a decimal. And I can turn this decimal into a percent by multiplying by 100. So entertainment is 22% of my expenses. And I can do the same for the rest of the categories. So clothing is 50% of my expenses, cell phone is 11% of my expenses, and lunch takes up 17% of all my expenses. Now, just to make sure that I did this right, I'm going to add up all my percents, and I should get close to 100. It might not be exactly 100 with rounding errors if I rounded my numbers, but it should be really, really, really close to 100%. So if I add up 22 plus 50 plus 11 plus 17, I do in fact get a total of 100%. So that's good. I did this right. Now, how do we figure out what angle to make each piece when we build our circle graph? Well, one thing you need to know is that there are 360 degrees in an entire circle. So if entertainment is 22% of my expenses, the piece of the pie is going to be 22% of my 360 degrees. So how do I calculate 22% of 360 degrees? It's 0.22 times 360. So when I do that calculation, I end up with 79 degrees. So when I build my circle graph, my piece for entertainment is going to be created using a 79-degree angle. And I can do the same for the rest. Clothing is 50% of my expenses, so it's 50% of the circle, so it's 180 degrees. Cell phone is 40 degrees, lunch is 61 degrees. And just to make sure I did it right, I can add up all my angles here, and it should be adding up to a full circle, 360 degrees. So if you add those up, 79 plus 180 plus 40 plus 61, we do in fact get 360 degrees. So I know I did this right. Okay, so I've got all my different categories with the size of each piece of my pie. So now when I go to build my pie chart, I can just draw a circle. And then from the center of my circle, I'm going to draw a line to the edge of the circle. Now you may or may not have a protractor with you right now. It's fine. If you don't, we can just pretend. So I usually start with the biggest piece. So the biggest piece is clothing. It takes up half of the circle, 180 degrees. So I would take my protractor, line it up on the line, and then measure an angle from here, 180 degrees. Okay, and now we can label it, and we've got our biggest piece. Now I go to my other pieces. So I've got entertainment is a 79-degree angle. So I would, again, put my protractor along this line, and this time I'm going to measure a 79-degree angle up. And I'm just eyeballing this. I don't have a protractor on my iPad here, so I'm just estimating a 79-degree angle here. For my other spaces, I have cell phone, which is a 40-degree angle, and lunch, which is a 61-degree angle. So I can use my protractor to measure that. And once I've made my measurements, I can just label my pieces, and now I have a pie chart, or circle graph. And it looks pretty good, I think. The last thing I want to talk about is histograms. So I've got some data here. We're going to make a histogram of this. So Bob measured the heights of all his cousins. So you can see he has a lot of cousins, and he measured the height of each of them. And they've been rounded to the nearest centimeter. So we're measuring heights. Heights are continuous. You can have someone measuring 170 centimeters tall, 171 centimeters tall, and anything in between. So this is continuous data. And because it's continuous, we're looking at either a histogram or a line graph. Now, I already told you that we're going to make a histogram, but the reason we're not going to use a line graph is because the line graph is usually used for showing a trend. We're not really looking for a trend here. So the purpose of this data is just to see all the different heights. Okay, so in order to make a histogram, we are going to look at the different intervals. So here I have the heights between 130 and 140 centimeters. We're going to count up using a tally how many heights are between 130 and 140, and we're going to get the frequency. So how many times that occurs. Then we're going to count up all the heights that occur between 140 and 150, then between 150 and 160. So we have all these different intervals, and we're simply just going to count up how many heights are in each interval. Now, I just want to draw your attention to these brackets. So you'll notice I have square brackets on the left and round brackets on the right. And the difference is, in this notation, square brackets would represent this number is included in the interval, whereas the round bracket indicates that this number is not included in the interval. So for example, if you have someone with a height of exactly 140 centimeters, you would not include them in this interval because there's the round bracket there, but you would include them in this interval because 140 has the square bracket around it. So that's just notation to indicate what's included and what's not included in each interval. Okay, so let's count up how many heights are in each interval. I've set it up so that you can just do a tally, and then once you have the tally marks, you can just add them all up to get the frequency. So I'll show you what I mean. Here I have a height of 154. Well, that's in this interval. Here I have a height of 175. That's in this interval. 166 is in this interval. And I can just keep building my frequency chart. So once I have tallied up all my heights, I can complete my frequency table. So I've got 4 heights between 130 and 140, 2 heights between 140 and 150, 7 heights between 150 and 160, etc. Now I can set up my axes. So on my x-axis, that's where I'm going to have my heights. And on my y-axis, that's where I'm going to have my frequency. So the things you want to make sure you consider are that your axes are divided evenly, so they're evenly spaced on the scale. And you want to make sure that all your intervals are included. So for heights, I want to start at 130 and go up to 200, and I'm spacing it every 10. So a lot of people start labeling with these on the axes, but what you want to do is just use the numbers. Label it the same as you would a line graph. So start at 130, there's 140, 150, 160, 70, 80, 190, 200. Okay? So now when we look at our frequencies, well, I have 4 heights between 130 and 140. So between 130 and 140, I'm going to draw a bar that has a height of 4. And then I have 2 heights between 140 and 150. So between 140 and 150, I'm going to draw a bar with a height of 2. And I just do the same for the rest. So when you're all done, you'll get a nice histogram. And this last example also involves a histogram. This one shows the heights of different black cherry trees in an orchard. So here we have the different heights and the frequency for each interval. So the question is, how many trees have a height of at least 65 feet, but are shorter than 80 feet? Okay, so at least 65 feet, but shorter than 80 feet. So we're looking at this range right there. So I can go up to my graph and I can say, well, there's 3 trees in that interval, there's 8 in this one, and there's 10 in this one. So if I want to know how many trees are between 65 and 80 feet tall, I'm just going to add up all the trees that are in that range. So I have 3 plus 8 plus 10. So there's 21 trees that are at least 65 feet but shorter than 80 feet. The next question is how many trees have a height of at least 80 feet? So that would mean 80 feet or taller. So when I look at my histogram, well, here's 80 feet or more. I'm looking at this range over here. So I'm going to add up the frequencies for these two bars. So there's 5 trees between 80 and 85, and there's 2 trees between 85 and 90. So overall, there's 7 trees that are at least 80 feet tall. Okay, how many trees are in the orchard? Well, I would just have to add up all the trees. If I have another 3 over here, I just have to add up 3 plus 3 plus 8 plus 10 plus 5 plus 2. So there's 31 trees in the orchard. Okay, this last question, a lot of people find difficult. Find the percentage of trees which are at least 80 feet tall. Okay, so there's 7 trees that are at least 80 feet tall, and there are 31 total trees. So I can set that up as a fraction. I have 7 out of 31 trees that are at least 80 feet tall. When I do 7 divided by 31 in my calculator, I get about 0.226. So rounded, that's about 23%. So I can say 23% of these trees are at least 80 feet tall. So what you need to be able to do from this lesson is identify what type of data you have, so either categorical or numerical, so that you can determine what type of graph would be the best to display that data. Once you've determined that, you'll need to be able to make the graph. And we're going to focus the most on histograms. So you really need to be able to read a histogram, and you need to be able to make a histogram. I have practice questions listed for you here in the textbook. But if you have any questions at all about this, please don't hesitate to ask me, and I will do my very best to help.